Most people can point to a moment when AI arrived. A chatbot that suddenly sounded human, a photo generator that made something believable in seconds, a headline about machines replacing jobs. It feels like a switch flipped. One year the technology is a niche curiosity, and the next year it is everywhere. But that feeling is mostly about visibility. What changed wasn't that intelligence appeared out of nowhere. What changed is that a long chain of quiet systems became easy to touch. For a long time, the public version of AI was a single idea, a machine that thinks, something like a brain in a box. You feed it facts, it reasons, it produces answers. In that mental picture, progress is about making the brain smarter, more logic, better reasoning, a bigger library of knowledge. And when a system starts writing, drawing, or speaking convincingly, it looks like the thinking finally worked. That story is simple, and it fits how people talk about technology. One breakthrough, one moment, one invention. That mental model also fits how products are experienced. You don't see the internal plumbing of your phone. You see an icon. You tap it. It does the thing. The experience makes the system feel like a single object, not an ecosystem. Even the language nudges the same way. AI sounds like one thing, like electricity or the internet, a substance, a force, something that arrives as a unit. But the reality is that modern AI is less like a sudden invention and more like a gradual takeover of the boring parts of decision-making. It crept in through the places where people already relied on automation: sorting, ranking, routing, filtering, predicting. The first wave didn't feel like intelligence because it didn't talk. It just made the world slightly more shaped. A spam filter that caught more junk, a credit score that decided faster, a recommendation list that got stickier, a search engine that guessed what you meant. Those are not presented as AI in daily life. They're presented as features. Under the surface, those features have a shared structure. They start with an environment that produces an absurd amount of data: clicks, purchases, GPS pings, sensor readings, timestamps, forms, logs. Then they build a pipeline that turns that mess into inputs a machine can use. Clean it, label it, compress it, standardize it, decide what counts as success and what counts as failure. Only after that do you train a model to map inputs to outputs. And even that part is not a single technique. It's a family of methods that work because the world is repetitive enough to be predicted. In other words, the creep wasn't just better algorithms. It was the industrialization of prediction. Companies and institutions learned how to treat human behavior as something that can be measured, stored, and fed back into systems. Once that infrastructure exists, prediction becomes a normal tool. It stops being a research project and becomes a line item. Not can we build AI, but can we reduce errors by 2%? Or can we cut review time in half? Or can we keep people on the platform longer? That's how it slips into place. Not as a dramatic replacement of humans, but as an optimization that no one feels responsible for. Another reason it crept in is that it piggybacked on existing software patterns. Modern organizations already run on dashboards and queues. Work becomes tickets. People become entries in databases. Decisions become drop-down menus. Once life is structured like that, it becomes easy to insert a model in the middle. Instead of a person reading every request, a model routes them. Instead of a human scanning every image, a model flags the suspicious ones. Instead of an editor deciding what's relevant, a model orders the feed. The organization doesn't need a humanoid machine. It needs a machine that can handle volume. The real acceleration came when these systems started feeding each other. Better sensors and cheaper storage made it practical to collect more data. Better data made models more useful. More useful models justified building more pipelines. More pipelines generated more labeled examples. And the more you do this, the more the model stops being a special feature and becomes an invisible layer across products. It's no longer the AI team. It's the system. It sits next to analytics, security, and search. It becomes infrastructure. Then something new happened. A class of models started producing outputs that look like human expression. Text, images, voice, code. This is the point where the public noticed. But it still didn't arrive suddenly. The ability to generate convincing language is the result of scaling a method that had been around for years, plus the build-out of huge training pipelines and enormous computing capacity. Training these systems isn't like installing an app. It's more like building a factory that can digest the internet and then paying the electricity bill to run it. And the training process itself is less mystical than it looks from the outside. A language model becomes useful by absorbing patterns in text. It learns what tends to follow what. It learns style, structure, common arguments, and the shape of explanations. It doesn't store the world like a human does. It compresses a statistical portrait of how language behaves. That portrait can be surprisingly powerful because language contains a lot of the world. If you can predict language well, you can imitate many forms of knowledge, including the tone of expertise. But that still doesn't make it a standalone mind. The system you interact with is usually a stack. The model generates candidate outputs. Other components filter them, steer them, and decide what is allowed. Sometimes the system retrieves information from a database or the web. Sometimes it consults tools. Sometimes it follows templates. Often it's guided by training that rewards answers people prefer, not answers that are objectively correct. The intelligence is distributed across engineering decisions. What data to include, what behaviors to reinforce, what risks to avoid, what costs are acceptable, what latency users tolerate. That's why it felt like it crept in. The parts that matter are mostly not visible. You don't see the data collection systems. You don't see the labeling operations. You don't see the compute farms. You don't see the model monitoring. You don't see the quiet failure cases that were patched over. You see a clean interface, and you see it only after the system has become stable enough to be sold. Once it's in place, the second-order effects start to show up. When prediction becomes cheap and widespread, the world starts adapting to it. Some changes are obvious, like automation of routine tasks. But many are subtle. Decision-making moves upstream. Instead of people deciding directly, they decide what the model should optimize. Instead of arguing about a single decision, organizations argue about metrics. This shifts accountability. If a system produces a bad outcome, it's easy to blame the model, but the model is mostly reflecting the structure it was embedded into. Another effect is homogenization. Systems trained on broad averaged patterns tend to produce broad averaged outputs unless pushed. That can make communication flatter. It can nudge writing, design, and even thinking toward what is most common and safest. At the same time, it can amplify what already performs well in the system's feedback loops. The styles that get engagement, the formats that spread, the arguments that win attention. The technology doesn't invent those incentives. It accelerates them. There's also a dependence effect. When a system starts working, it becomes the default. People stop building alternatives. Skills atrophy in the background. Workflows reorganize around the tool's strengths and weaknesses. Then the tool becomes hard to remove, not because it's perfect, but because everything around it has been restructured. That's another way AI crept in. Not just into devices, but into habits, budgets, and expectations. And finally, the boundary between automation and judgment gets blurrier. A spam filter feels harmless. A recommendation engine feels like convenience. But the same pattern, predict and rank, can be applied to more sensitive areas. Hiring, lending, policing, healthcare, education. The system doesn't announce itself as AI. It announces itself as efficiency. And because the model is only one layer in the stack, it can be difficult to locate where a bias or error actually enters. The creep is institutional, not just technical. So the better way to frame the last decade isn't that intelligence suddenly appeared. It's that the infrastructure for shaping decisions became dense enough that it started producing experiences that feel like intelligence. AI is not a single device that arrived. It's a layer of prediction embedded into systems that already run modern life: platforms, logistics, finance, media, administration. When that layer became expressive, when it started speaking and drawing, it finally became obvious. Seen that way, the surprise is not that AI is here. The surprise is how long it was already present before most people had a name for it. Thanks for watching. If you like what you've seen here, please like and subscribe. It really helps out. And if you have a topic you would like us to cover, let us know in the comments.